Good afternoon, my fellow intellectuals. Today we are going all the way to Levi Manawasa Medical University again. So to introduce myself, I'm the Universal Data Boy, or you might as well call me the A Plus Ambassador, David C Banda. You can email questions to this email, davidcbanda237@gmail.com, or you can send the question in WhatsApp form to this number, or if you need any kind of help in terms of academics. So now the question that we're handling today is on circular motion, of course, as you can see on the screen, and then we'll be we'll be handling it just like we always do. So remember, subscribe to this YouTube channel if you have not yet subscribed. So now we go to the question, direct to the question. It's question 5. The drivetrain of a bicycle has wheels 76.3 centimeters in diameter and pedal cranks 17.5 centimeters long. The cyclist pedals at steady angular rate of 76 revolutions per minute. The chain engages with a sprocket front sprocket of 15.2 centimeters in diameter and rear sprocket 17.7.00 centimeters in diameter. So now we are being told now to do the questions down here. Question A rather says calculate the speed of a link of the chain relative to the bicycle frame. So now we can start by acknowledging one thing, and I actually like this question because it lets you understand one thing about angular velocity and linear velocity. So now allow me to demonstrate this. So now if we have an angle theta there, the angle is still theta. So now, but then this distance here, it's not the same as this distance, or this distance is longer. Now remember, distance in in angular acceleration rather is theta. So now meaning that the angular velocity in circular motion doesn't really change. The angular velocity is still the same despite the radius. But then we can see that for the linear speed, because the linear speed is equal to velocity is equal to distance over time, it depends on the distance. This distance keeps on increasing. So as the radius keeps increasing, for example, the radius here is smaller than this radius. As the radius keeps increasing, you can see that the distance will increase, and thus the speed, because for a particle, for anything, an object that's here, to come from there to there, it will actually cover a bigger distance over the same period of time, and thus the speed will be the same. I want you to really understand this about about circular motion in general as a whole, because this will really help you before you even go to the question. This will really help you understand something about the linear velocity and the angular velocity. And then angular velocity it has this symbol, and then it will always have this symbol. That's the angular velocity. Then the linear velocity will have the v, or you can write it like that. It doesn't really matter. So when you're told to find the angular speed, find the angular speed. When you're told to find the just the speed, just find the speed. Assume it's linear. When it's angular velocity, you will always be told. So now let's collect our data. Now. From our data, we can see that the wheels they have a diameter of wheels. We can put diameter. The wheels have a diameter of 67.3 centimeters. We can convert this 67.3 centimeters to meters, because that's what we really need. This just 67.3 times 10 to the power -2 meters. Or you can just calculate it. You can use conversion factors, you can use anything, but you still arrive at the same answer. Divide by 100, it's still 0.673. And understand, this is the same as this. You can use any of these in your computations, For example, 67.3 exponent negative 2 still arrives at the same thing. And then we have our pedal cranks. So we have our pedal cranks. Collect your data. We have our pedal cranks being equal to 17.5 centimeters. It's important to change to SI units here because it will help us in the question, because you can just forget and write it directly as it is, but then when you convert here, you actually not find a hard time. So that's 17.5 times 10 to the power negative 2 rather, meters, which is the same as 17.5 divided by 100, right? Divided by 100, which is 0.175 meters. What other data that we have? The angular speed. Angular speed of the pedals as the cyclist keeps riding is 76.0 revolutions per minute. Right, that's the angular speed. So we go on, we check out the other thing that we've been given is this front sprocket. So for those of you who don't know sprocket, it's that thing that's where a chain, the thing that a chain goes around on. It's let me just do a rough drawing. It's like round, and then you have a chain there, a chain going around around this thing. Of course, attached. This is what we call the sprocket. We have two. There is one where they are the pedals. So we have our pedals there. We have our pedals, and then we have one at the back. So now this one is called the front sprocket. Front sprocket. It has a diameter, front sprocket diameter of 15.2 centimeters, which is the same as 15.2 times 10 to the power negative 2 meters, which is just equal to 15.2 divided by 100. Of course, we know it's 0.125, but then you can never be sure in a physics problem. You always have to consult your calculator because you have that at your disposal. Never lean upon your own understanding, unless of course you're in a hurry. That's when you can take the risk. So now we go to the rear sprocket. The sprocket at the back, it's been given a diameter of 7.00 centimeters, which is equal to 7 times 10 to the power negative 2 meters, which is the same as 7 divided by 100, because this is a conversion factor, 0.07 meters. So that's all for our data. That's the data we've been given in the question. If you ever know anything else, it's something that we're definitely going to find from the question, from the data that we've been given. We can collect more data from this data, but then just give the data that you've been given in the question. If you need to find anything more, you are going to show it in your calculations. So now A, calculate the speed of a link of the chain relative to the bicycle frame. So now this chain is rounding, so we think it has links, so now if we consider just this link, we want to calculate its speed, so now the speed, as I told you, we're told to find the speed, so we must find the linear speed. When we're told to find the angular speed, find the angular speed. So now this is the linear speed. Now linear speed is given by r w, just like this, r w, the radius times the angular acceleration. So now we can go ahead and find this one, but then remember the radius we've not been given in the question, but then we've been given the diameter. Thus we know that we can definitely find this one. And then we've been given we've been given the angular speed, but then it's in revolutions per minute, so we have to change that. So now the radius will just be half of that, will be half the diameter. So we're going to indicate that in our question anyway, but then my concern is the angular acceleration. It's in 76.0 revolutions per minute. So we're going to use conversion factors for this one. Our first one will be, we know one revolution, we'll put revolution here so that it can cancel with that one. One revolution is equal to 2 pi rads. And then again we use another conversion factor, that is 1 minute. 1 minute, we put it on top so that it can cancel, is equal to 60 seconds. If you're ever wondering what to put down and what to put up, always remember you have to make them cancel. If you put both of them down, they'll just multiply each other and they'll be squared at the end of the day. And remember, put what is on top must be equal to what is down. So 1 minute is equal to 60 seconds, because when you multiply something by 1, it still stays the same. And then when you divide something by itself, the answer will be 1. So now when we divide 1 minute over 60 seconds, it's 1. But then we're going to use it in our question, so as a conversion factor. But then actually remember that this is just equal to 1. So we're not actually changing anything at all. We are just changing the unit. So we are going to manipulate it here and there. I hope you know how to go about this one. And if you don't know, check out my video rather, that explores more on this one. So now we are going to have these cancelling, the revolutions they'll cancel, the minute will cancel, then we're going to have 76 revolutions times 2 pi, all that 76 revolutions divided by 2 pi, 2 pi multiply rather 76 times 2, what's happening, times 2 pi, yeah, all that we're going to divide it by 60. So now we have our angular speed, but then now it's 77 rather 0.9. We can put this as 96. We can take it to 3 significant figures, because those are the significant figures in the question. Remember, when the significant figures are not specified, use the ones in the question. So when you check out the question, 15.2, 7.00, that's 3 significant figures. So we're going to write 3 significant figures here. 77.96. Now it's in rads, because the rads will not cancel and the seconds will not cancel. So we're going to have rads on top, then down we're going to have seconds. So now you've converted the angular speed. So now to find the velocity of a link on the chain. Now remember, this chain is rotating on the front sprocket. So now this, we're going to consider the radius of the front sprocket, because that's where the chain is rounding the chain link. When you consider a link, it's going according to the angular speed for this one. So we're going to consider the angular radius, just the radius, not angular, it's just a radius. So the radius for this one, and then we're going to consider its angular velocity that's there. So the radius for the front sprocket is 15. Let's use 0.152, but then we're going to divide it by 2, because this is the diameter. That we are going to have 7.96. So that's our velocity will now be equal to 0.152 divided by 2 multiplied by 7.96, we're going to have our answer being equal to 0.60. Remember three significant figures, 5 meters per second. That's where I found our speed, and those are the units definitely. So now in part B, we are being told to calculate the angular speed of the bicycle's wheels. Now, one thing that we have to remember is the back wheels, of the bicycle are being driven by the rear sprocket. So now there's this thing, then there's the other sprocket there, then we have our wheel there. So now this wheel is going in this angular velocity. So the angular speed for this one is the same as that one, because the only thing that's different with this sprocket and the wheel is the radius. Thus it's going to have a different a different linear speed, but then it's going to have the same angular velocity. So see the principle that I was talking about. So now we can start. So we use the same formula. V is equal to RW. That's we're finding this W. So when you divide both sides by R, by R, we're going to have W being equal to V over R. So now W is equal to, which V are we going to use? We are going to use the V that we found here, because this velocity, the linear velocity of the chain, it will be the same, because this chain, as much as it is round in there, it is also going to go this side. So we're going to have 0.605 divided by the radius. The radius is the radius of the rear sprocket is 7. We can use now this one. We see how this one works. 7 times 10 to the power negative 2 divided by 2. And remember, we're dividing because these are the diameters. Do not confuse diameters with the radius. So now we can divide. We can start with the denominator because that's what's easy. So we're going to have our 7 exponent negative 2. This is just the same as 7 times 10 to the power negative 2 divided by 2. And then we're going to get 0.605. We're going to divide it by the answer. So our answer is now 17.3. That's rads per second. Remember the units, and then now we're going to find C. So now our C is telling us calculate the speed of the bicycle relative to the road. Now the speed of the bicycle relative to the road is now the speed of these wheels. So if these wheels are going at a different speed, then definitely you will be going at the speed that the bicycle will be going on will be the same speed as the speed of the wheels. That's why when you have a bicycle with small wheels, it will be different with the speed that a bicycle with bigger wheels have, even if they have the same angular speed. So now we can go to question C. So calculate the speed. So now the speed, this is V. We're now finding the speed, not the angular speed. So we're going to find the V, which will be in meters per second. So now we have our radius. Now which radius are you going to use? We're going to use the radius of the wheels, right? Just as I said. So now we're going to have this is the diameter, so we're going to divide it by 2, 0.673 divided by 2. We're just multiplying by half, it's all the same thing. Then we're going to use this same radius, this same angular speed, which is 17.3 rads per second. So when you cancel out these units, if I thought you use units in a calculation, but I prefer to put them in my final answer, 0.73 divided by 2. But it's also important to go with your units throughout. It really helps. So I'm going to say 17.3 multiplied by the answer, we're going to have our angular speed being 5.823 significant figures meters per second, and then if our calculations were correct, the answer will come out like this. If any of our calculations were wrong, it might be on the calculator, but then the principle is the same. When you apply this principle, you can be given different figures. You cannot be given a bicycle, you can be given a car, you can be given maybe it's a multiple choice question, and then they ask you to say what happens when we maybe double the radius. What happens to the velocity when we double the radius? We're going to see to say doubling the radius will actually also double the velocity, but then what will happen to the maybe the angular velocity when we change the radius? We see that the angular velocity is not affected. That's why you'll find that just by answering these questions, you can even answer some multiple choice questions that come. There are some conceptual questions just try to test your brain. So be on the lookout for them. Then remember to subscribe to this channel and tell others also about some. You can share this to your groups. You can share with friends who may find it interesting, and also remember to subscribe to this channel. And if you found this video helpful, please leave a comment. And also, if you have any other suggestions, leave a comment. If you want your questions to be answered, you can send the questions here. So for me, David Banda, the universal data boy or the A+ ambassador, it's bye bye.